Hello friends, welcome to Engineering Funda family. In this video, I'll be discussing about IoT components and IoT levels. IoT levels means how we can deploy IoT system. So in general, there are 6 levels. Means in general, there are 6 ways by which IoT system can be deployed. But before you understand how to deploy IoT system, you need to understand IoT components. I have explained architecture of IoT system even. Here I'll be explaining you each and every component of IoT in great detail first. After that, I'll explain you how different IoT deployment models are there. So let us talk about IoT components. So when you talk about IoT components, first IoT component is device. Device means AND node. So with AND node, there will be embedded system which will be having sensors and actuators. Sensors are sensing physical data that will be given to cloud, and actuators are giving physical response, and that physical response will be driven by device based on commands given to the device. So here there will be device. This device will be giving physical data to cloud, and this device will be giving command to the actuator, and that command will come from internet, right? So here device means physical device that allows identification, remote sensing, actuating, and remote monitoring capabilities. Now let us talk about second component, that is resource. See here, resource means software elements which are there inside device. Here device will be embedded system, consider that. So here with device, we will be having some software elements. So with the use of software elements, IoT device will be interacting with internet, right? So second component is resource, which means softwares are there inside IoT device which will be providing interaction of that device with network, right? So see, resource means software components on IoT device. So the device in which we will be storing some softwares or programs by which we will be doing accessing, processing, and storing sensors information or controlling actuators connected to the device. Here resources include software component that enable network access for device. So here, as I have told you, we are deal with to provide information to network based on whatever data that we sense, and we are deal with to provide signals to the actuator, and that will come from internet. And to have it, you need to have some softwares inside device. That is referred as resources over here, right? Now third component, that is controller service. See, controller service is a native service that runs on the device and interacts with web services. So here we need to have access of information with the use of web services that is being controlled by controller services. So the controller service sends data from the device to web service and receives command from the application for the device, right? So here controller services means what? Controller services means here that device will be accessing internet, and that will happen with the use of web services, right? So there will be some protocols, like as if you talk about REST services, then in that HTTP protocol will be used by which we will be accessing web services, right? If you want real-time bidirectional communication, then you will be using WebSocket, right? So here we need to access internet with the use of web services, and that will be given by controller services. Controller service means here device will be accessing internet. To access internet, you need to have web services. To have web services, there are two ways in IoT. One is REST and second is WebSocket, right? In both, we are deal with to have web services. By those web services, application from internet can give command to the device, as well as device can forward data on internet, right? Now fourth component of IoT, that is database. That is quite simple. There can be two types of database: local storage database or database on cloud, right? So that is how database can be there. And database means data that is been provided by different end nodes, and on that database application will run, and application will give commands to the actuators, right? So database can be local or it could be on cloud. See, next is web services. I have told you there are two types of IoT services. In logical design of IoT video also I have explained both of those two services. So here I will not discuss that in that great details. But consider there can be REST principle or WebSocket protocol. In REST, we are having HTTP protocol, right? And for bidirectional full duplex communication with internet, we have WebSocket protocol. So WebSocket protocol that we usually use for real-time applications. And if some delay is allowed, then we can have HTTP protocol with the use of REST principles, right? Now let us talk about next component, that is analysis component. See, once you have data on cloud, we are deal with to have analysis. So analysis is done by varieties of ways nowadays in 2023. Here analysis can be done with the use of artificial intelligence, with the use of deep learning, with the use of machine learning. There are some algorithms even with the use of big data analysis also analysis can be done, right? So there are varieties of ways by which we do analysis, and by the analysis we can improve and optimize our application, right? So that is how analysis component is there. And last one is application component. See, on internet we'll be having application. In application we will be defining features for user. So in mobile or in computer you will be using application. So manually you can give command to the application, as well as automatically also your application can give command to the devices, right? Like for example, in farm you want to sense moisture, right? Now as if moisture is less, then automatically signal can be given to the actuators by which you can pump the water inside your farm. As well as if you want to feed water manually, then also you will be giving command by your application, right? So application gives interface to your IoT system, right? So that is what the part which is there at the side of user. So that is how different components are there. Now let us try to understand how IoT levels are there. So IoT level number 1, that gives you idea about simplest IoT system. So simplest IoT system will be having single node only. So level 1 is having single node in which we will be sensing the data, we will be performing actuation part, we will be storing everything with single node only, right? Here IoT systems are having lower cost and lower complexity for solutions, and here we don't need complex computational intensive services, right? So here on cloud everything will be very simple, single node will be there, and this system is therefore low cost, right? So here, see here locally I'll be bisecting this, and here there will be things on cloud. Things on cloud means things will be there as per internet services, and here physically devices will be there, right? So here we'll be having one node that will be having sensors and actuators, right? So device will be connected with resources. Resources means softwares, and then there will be controller services which will be connecting it to internet. That is single node only with level 1. So there will be database, and this database will be interacted with internet services as per REST or WebSocket, and then there will be application by which we can give command. So here in IoT services there are two IoT software services on web. One is REST, which will be using HTTP protocol. Second is WebSocket, that is used for bidirectional full duplex communication, right? So here single node is there, and for low cost application we can have level 1 IoT services. Now let us have second IoT service, that is level 2. See, in level 2 also we will be having single node. So that will be performing sensing and actuation part. With that, now data is stored in the cloud. So previously we were not been storing data on the cloud, right, with level 1, but with level 2 we will be storing data on the cloud, right? And application will be there as per cloud based application. So you can observe here we are having local things, and here we are having cloud things. So here a single node will be there. With that we'll be having device which will be interacting with resources means softwares, and then there will be controller services means now we can access data on cloud, right? So now see, that is how from controller services we will be accessing data on cloud, and now there will be database, right? Whatever data that we are sensing over here, and with the use of REST or WebSocket services, application will be executed over here, right? So that is how level 2 services will be there. So in level 2 services, we are having single node only, but here we will be storing data on cloud. In level 1, we are not storing data on cloud. Here also, computational requirement is very simple. It is not extensive. You see here in level 2, data will be big on cloud, right? But analysis requirement is not computationally intensive, and it can be done locally itself. So here only we can have that computational complexity. You don't need to go for intensive calculation over here on cloud, right? So that is how level 2 is there. Now let us see how level 3 is there. Level 3 is also based on single node only, right? But in that single node, we are having only one additional feature compared to level 2. In level 2, we were not been having complex computational skills, right, at cloud. But in level 3, there will be intensive calculation which will happen on the cloud. So that is how things are different. You can observe here, we are having single node locally. So device will be there interacting with resources, means software, and then it will be interacting with controller services, that is for communication with internet. And then it will be communicating with cloud storage and analysis, right? So here you will be observing database will be there, in which for application access, REST or WebSocket services will be there with app. And here execution will happen with this node as per cloud, but only difference is here computational complexity will be bit intensive. In level 2, it is not intensive. So in level 1, single node is there. Data will not be stored on cloud. In level 2, data will be stored on cloud and application will run on cloud, but computational complexity is not intensive. In level 3, computational complexity will be intensive over here, right? So that is how differences are there, right? Now let us talk about level 4. So in level 4, see, there will be multiple nodes. In level 4, there will be multiple nodes, right? So multiple nodes will be interacting with cloud, right? Here multiple nodes will be interacting with cloud. And here if you observe multiple nodes that we are having, which is interacting with cloud, right? So here two devices that I have shown, that is interacting with resources. So that is local software on device. And here it is connected with controller services, means now with the use of controller services, these devices can interact with internet on cloud, right? So this controller services is connecting these devices to cloud. So on cloud there will be database which is connected with REST services. See, REST services are having bit lower computational complexity, right? It is not there for real-time communication that you can say, right? It is based on request reply system. HTTP protocol will be there, right? And here there will be application, right? And if you observe here, REST socket or web socket communication that could be provided over here. But usually REST services will be there as we need to have lower complexity relatively, right? Complexity is high. It is not like complexity is less over here. Here we are having multiple devices. So obviously compared to level 3, complexity will be high, right? But here we will be using REST protocol in majority. There are always two options, REST or WebSocket. For bidirectional full duplex communication, we should be having WebSocket protocol. For simplex communication or for unidirectional data transfer, we can have REST protocol which functions on HTTP. So in majority of IoT level 4 application, we'll be having REST services only, where multiple nodes are there. With level 1, 2, 3, single nodes will be there, right? And you will be observing here, observer node is observing all these devices at local level as well as at cloud level. And there will be analytical IoT intelligence component by which we will be executing our application. So here, let me show this part as well. See, in level 4, we are having solutions for multiple nodes. And here data is big. Analysis requirement are computational intensive, but that is not that intensive as WebSocket, right? As we are having REST services. Now let me show you level 5 step by step. So you will be having fair enough idea like how differences are there. The reason is based on differences only you will have to understand all those things, right? So in level 5, see, we are having multiple AND nodes, right? In level 4 also we are having multiple AND nodes. Now if you see here, these multiple AND points that is connected with coordinator. This coordinator could be gateway, right? This coordinator could be gateway. And then we are interacting with cloud services. So here you see endpoint devices are there. Endpoint devices could be embedded system or it could be routers. So these endpoint devices are interacting with coordinator, right? That is interacting with resources, means software on that device. And to have communication with internet, there has to have controller services. So this endpoint devices are transferring data to this coordinator that you can observe as per this diagram. And now this coordinator will be interacting with cloud storage. So on cloud storage, you can observe here database is there, and here REST services is there, and here communication is happening with application with the use of REST WebSocket communication. Here at level 5, REST and WebSocket both are happening with equal quantity, that one can say, and here complexity of computation will be very high, right? Here there will be observer node which is observing locally as well as on cloud, and here exchange of information that will happen with the use of IoT intelligence, right? But here if you observe one difference compared to level 4, in level 4 multiple nodes were there, but in that there were no coordinator. In level 5 there is a coordinator, right? So that is how things are different. In level 4 multiple endpoints were there, but there was no coordinator, right? So here when you talk about level 5, then here multiple end nodes will be there and one coordinator node will be there. End nodes that perform sensing and actuation part. Here coordinator will be collecting all the data from the end nodes and it will send it to cloud. Data is stored and analyzed on the cloud, and application is cloud-based application, right? And with level 5, IoT systems are suitable for solutions based on wireless sensor network. So here you will be observing this level 5 is very nearer to wireless sensor network kind of IoT system. I have already made video on wireless sensor network, right? You just go through it. So level 5 is IoT system based on wireless sensor network, in which data involved is very big and analysis requirement are also very intensive, right? Now there is last system, that is level 6. So level 6 is also very nearer to level 5. There are little bit differences that you need to understand. Here also there will be multiple monitoring nodes. Here see, these monitoring nodes can be coordinator, that you can say, it can be router, or that can be endpoint, right? All the possibilities are open over here. The reason is IoT level 6 is highest IoT system that one can say, right? Here also you can observe multiple devices are there that is interacting with resources via software, and here controller services is there that is providing interaction on internet. And see, here there is a centralized controller. So that centralized controller that is there at cloud side, right? That is there at cloud side. So that is controlling all these devices. That centralized controller that was not there in level 5. Here this additional feature is there, which is centralized controller. Otherwise almost everything is identical. You can observe here. Then after cloud storage and analysis part will come. So here data with the use of database, REST WebSocket services are executed, and here application will provide interaction to the all the devices, right? Here observer node will be there at local and cloud level, and complexity of analysis that is very high over here, right? So only one thing that we are adding, that is centralized controller, right, in level 6. So let me discuss about the points which I have it over here for level 6. In level 6, multiple independent end nodes will be there that will be performing sensing, actuation, and it will be sensing data on the cloud. Data will be stored on the cloud. Application will be cloud-based application. Analytics component analyze the data and store the results in the cloud database, right? The results are visualized with cloud-based application. So here we are having data prediction kind of things, right? Where we are visualizing the results even. Here we are having centralized controller, and see, centralized controller is aware about the status of all the end nodes and sends commands to the node, right? So here centralized controller that is having knowledge about all the nodes connected there, right? So that is how all 6 levels are there with IoT, right? So that is how different templates are there with IoT. I hope you have understood this. Still, if anything that you like to share, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.